All right, so these are all we call them parent functions because they are the originals, and every other function is basically just a transformation of these functions. So for example, the domain for any line that has slope will be all real numbers, and same for the range, because you can see, right, it goes all the way left and right. Okay. So right here goes forever. That's goes forever, left and right, up and down, right? So now, can you guys see the Desmos? That I just opened up? Okay, thanks. Okay, so here's the y equals x, the original. So if I add 2, it shifts up. If I subtract 2, it shifts down. So we call it the parent because you can just create different versions of the original to transform it. Okay. And I'll send you another PDF for what each transformation does. But if the number's out here, it moves it up. If it's time 2, it changes the slope. -1 shifts it down. Okay. This idea applies to all of your graphs. I don't think we're gonna mess with the step function, but that's all right. Okay. Let me see if I can find a sheet. This one's pretty good. Yeah, I like that one. Yeah, so check this out. See if it lets me. Wants me to buy something. It's lame. This. Here we go. This one's pretty good. It has a lot more details. I mean, it's in the notes and stuff, but just in case, here's some more information. But let's go through it. Right. So here's just a random function, f, the black one. If you do +3, well, it shifts up 3. Right. Now, they call this a vertical shift. So plus d goes up d. Minus d goes down by that same number. And you see how it only really affects the y part, because it's going up and down. So it makes sense that it's right here, right? I'm recording. Okay. If they multiply by the whole function by c, some number, it only affects the y, but it's times c, so it does a vertical stretch, so a stretch on the y. If it's a fraction less than 1, then it will shrink it vertically. It'll kind of compress it. A negative in front of the function will cause it to flip over the x-axis. That's when it does that reflection. Do you remember? Like, so that applies to all functions. So here you can see the visual. If we do ×2, right, narrows it, stretches it upward. You do +2, moves it up. If you do times a half, stretches it open. To -2 shifts it down. Reflection minus there. You can combine these ideas all together. Now, horizontal shifting, it has to be inside the parentheses. This will affect the x. So obviously it'll move on the x-axis. So the only difference is kind of opposite. So if it's plus a number, it goes to the negative side, the left side. If it's minus, it goes to the positive right side. So it's the opposite in here. Plus D means minus here. See that opposite sign here? So horizontal shifts have to be inside. Vertical shifts have to be outside. Okay. In a nutshell, that's what we're going to most likely be looking at. So let's get to the homework. So it's just a brief introduction. So let's look at our homework. Okay. Match the function with its name. So here they want to know, do you know what it's called? Well, it's not absolute squaring. It's none of the first four. It's the identity function, because whatever you plug in is what you get out, right? But plug in 1 and get a 1. So here they just kind of want you to know the names. So let's move on. The PDF I gave you has all the names. Okay. Consider the following. Write the linear function that has the given value. So basically, they're giving me 2 points. Find the function that'll go through those 2 points. Do you remember from your last math class how to find the equation of a line given 2 points? Does that sound familiar at all? No. The whole mx plus b and point slope form, all that stuff. So it's basically what this is just they have it in functional notation. So let's go ahead and figure this out. So f of 1 equal to 5 means 1 comma y. And f of 0 equal to 7 means 0, 7. So we have 2 points. We can call this x1, y1, x2, y2. Okay. Now, the formula I recommend using, the easiest one, is this: y minus y1 equals to m times x minus x1. So find m first. Before I can use it, I need the slope formula. So go ahead and write it over here. Does this look familiar? Okay. Just plug it in. So n will equal y2 minus y1 over x2 minus x1, which is 2 over -1, which is -2. Okay, so now use this guy. The y1, x1, you can use whatever you want. Doesn't matter. I'm gonna use the 1, 5, I guess. You could also use mx plus b, it doesn't matter. So there it is. So the function you're looking for is -2x plus 3. So there's no, we're not using y's, we're using f of x, right? So you just graph it, part B. Any questions on this first problem? Okay, you guys are good. Well, let me clear it then. Let's see what's next. Here we have piecewise functions. Have we talked about piecewise? I don't remember. So it's somewhat familiar, right? So all this is saying is you have two functions that are pieced together around this point here. So they just want us to sketch it. That's it. Okay. So it'll be the top line if we're below -6. So we plug in, well, okay. Plug in -6. We would get call it F1 and maybe more space than that. Okay. F1, F2. All this top one. F1, F2. We're just trying to keep our stuff together. If I were to choose -6, right, you would get -6 plus 2 for the first function, giving you an output of -4, right? If I do -6 over here, that would be half of -6 minus 7. So that would be -10. 22 points. So plug in one more below for the top one. We're only going to use it here for F1. So that would be -7 plus 2 equal to -5. So we have 2 points. -6 with -4 is right here. Right there. -7, -5 here. And just does this, right? Is less than -6. The line only goes that direction. Now the other one at -6, it says greater than, not equal to, right? Just greater than. So at -6 for the other function, we got a -10, which I can't even see. As such. Down there. That's not good. But what I could do is this. Do that. I just have to redo this. All right. So we said for the first one, -6, -4, -7, -5. The other one was -6, -10. So we have an open circle because it's not defined there. Now choose something above -6. I don't know. 0 just because it's easier, right? What would you get for this function? For F2? That's 0. Yeah, it's gonna be just -7, right? So ready? That should be 2 easy points to plot. These are the line things. What about crappy pictures? This one was that -6, -4, and -7, -5. Okay. All right. That's all they ask. But are you comfortable plotting the points? That's really what matters. It's the only thing they're testing us on is can you graph a piecewise function? Do you see the process or do you not see? All right, that's all there really is to say. I thought there was more to it, but we're just graphing two lines. Just need to make sure we understand that there's restrictions on both lines. That's it. That's why they're broken up like that. So no other questions then. Okay. Okay, here. Basically, we're just matching the graph. 4 plus x is just it's the identity line plus 4, but it has to be below 2. So do A or B make sense? For sure, B, no, because they're graphing x plus 4 past 2. This is supposed to be below 2. That doesn't even make sense. Now look at this line. Is this x plus 4? No, it has a negative slope, right? This is negative x plus 4, probably. All right. So it looks like it has to be which one? Yeah. C, because D has a similar issues as the other two. So yeah, C. The parabola begins x squared plus 2 after 2. So there's a parabola piece. It doesn't really look like one, but there it is. Anyway. This is a pretty short section. Do you guys see how you would do 12? If not, if you're good, we'll move on to the next section. Yeah. Let's do it. I think. What's the easiest way to go about it? What we could do is graph it ourselves on. I'm gonna graph it. I'm gonna draw it out on top of Desmos. That'd be better. I just need some graph paper. I believe that's how they have it from 4 to 10. Yeah. Okay. 4 minus x squared whenever we are below -2. So I need a spot to write that out. Let's see. We have 3 function groups. 3 functions. You don't have to call them F1, F2. You can call them whatever it is. Like, for example, what was the first one? First one was 4 minus x squared. Just write that. The next one was, I forgot, 4 plus x and x squared plus 1. 4 plus x and x squared plus 1. Okay. Sorry, yeah, my mind's elsewhere. So the restriction for the first one said below -2. Is that what it was? Yeah. But not equal to. But we do need to know what's going on at -2. And the restriction for the rest, I think, is around the same point, right? -2 to 0, and then a greater than 0. Okay, we'll come back to that. So 4 minus -2 squared would be 0, right? You guys agree? But now choose a number below, so we get our second point. 4 minus -3 squared. That would be 4 minus 9. Yeah. So we got our 2 points for the parabola. So -2, we got 0. -3, we got -5. And if you remember what the parabola looks like, it's shifted, it's reflected and shifted up 4, right? Basically, it'll be going down like this. Okay. Now the next one, -2 and 0, we need to find out. So in between those 2 points, it is doing stuff. It's a line, I guess. -2 to 0, it's a line. So we got to plug in -2 into this guy. So -4 plus -2 is 2. Gotta do 0. 0 at that guy would be 4, right? Might as well do 0 on the next one. That'll be 1. Okay. All right. So we have a line between 0 and -2. So at 0, we have 4. It was equal to, right? And both of them? So much to remember. Equal to and less than. Okay. At the 0, there is a hole there. Okay. At -2, we do have a point 2. I have a line right here. Line segment, I guess. Okay. Then we have another problem starting after 1. Double check. After 0. After at 0, we have 1. Greater than 0, so plug in another one. If I plug in 1, I get 2. We get a problem doing this. So we're basically, we have to know what the functions look like and then plot around it. Right. Give me one moment. Let's take a short break here and we'll see if you have questions. Give me 10 minutes. All right. Okay, so here they're just using the PDF that I sent. Let me go ahead and grab it real quick. This. Here we go. That's the horizontal shift, and then this is the vertical. All right. So the reflection is going to be caused by which one? Do you remember? Yeah, the negative f of x. Over here, if the plus c or plus constant is on the outside, what type of shift is this? Assuming c is positive. Look at the sheet. If it's outside, it is shifted upward by that number. So shifted up c units. If it's negative, well, you're shifted down c units. Okay. What about C and D? What type of transformation is that? So this one is kind of opposite. So if it's plus C inside, it's going to be shifted to the left. If it's minus C, is shifted to the right. So if we look at that PDF in the center there. Right. If it's plus, shifted to the left. If it's minus, shifted to the right. So left and right. No, I'm not writing. I'm just showing you the PDF. We're just looking at the definitions. Okay. Alrighty. So if this is some function f, obviously that would be a piecewise type. Sorry, spaced out. This whole thing is f. So on part A, what happens if you have a negative x inside? What type of transformation is that? Yeah, it's gonna be flip over the y. And since this doesn't have perfect symmetry, you should see a difference. So which one has this reflection over the y? Yeah, I'm thinking the first one. Let me see. Yeah. Let's check. Curious. On the bottom. And then Armstead. Yeah. Now I'm confused. Didn't I do it right? Oh, there's a check. Okay, cool. All right, part B. If F was this weird, dipper thing, what does a +4 do? Yeah, so the only one that's gonna be, which one does it have to be? Yeah, it has to, right? Does that make sense so far? Transformations? Okay. Times 2. What does this do to your y values or your function? I said we have a number, not a fraction. It's going to multiply all the y values, right? Vertical stretch. So which one looks like it was stretch upward? Yeah, 2f of x would double all your y values. So all the outputs that come out would be times 2. So the original graph would all be multiple, all the y's would be times 2. I want to say D. Let me see. Vertical stretch. C would be a horizontal stretch, right? Is that clear? The times 2? Basically, the y should be bigger if it's a whole number, if it's a bigger than a fraction, bigger than 1. Negative f of x minus 4. What does a minus do? The minus in front is what kind of reflection? Yeah, I'm gonna flip over the x-axis. So if it's not facing downward, it's wrong. So it has to be B or C. Yeah, minus 4. Yeah, someone said shifts to the right, so that's correct. So there's not much work to do. It's just more of a conceptual thing. Do you know what each type of transformation is? Yeah, C is moved upward. What about E? Yeah, down 3. I don't remember how low it was to begin with. Yeah, I think it's C. It was -4 down. So 3 more. Yeah, it would be that -7. That's right. Oh, here it is. Okay. Let's move on. Well, what would this do? Yeah, it's gonna double the X value. So let's see. Yeah. Oh, actually, it's the opposite. C times the number would actually divide that number. Interesting. So it creates a shrink horizontally if it's inside. If it's inside, it's the opposite. So horizontal compression or shrink times 2. So it should be more narrow. I'm sorry, it should be shorter. I think it's B. Yeah, it looks that way, Joshua. I want to say it's pretty much the rule, but for shifting, for stretching, yeah, the opposite from the uh, vertical stuff. Okay, look at the homework. The next one's the same deal, so let's go to 5. All right. So here they want us to work backward. They're telling us that the parent function is x squared. So what is this transformed version of that function? Yeah, it's shifted down 1, right? Does that make sense? It's a vertical shift. What about B? What's happening to B? Yeah. It's moved up 4 and flipped. Okay, so let's take care of that all piece by piece. So we know there needs to be a negative in front, right? And we know it's quadratic. If we're shifting left 2, what goes inside the parentheses? Yeah, it's going to be opposite, right? If we're going upward, what goes upward 4, we put plus 4. Yeah, and you can always do it on decimals to see, right? OG's right here. Was what was inside? Plus 2? So it's flipped, then shifted to the left 2 and up 4. There it is. So we're good. Their graph is different because they narrowed it down. So if we change the settings, right, -4 to 4 and -4 to 4, it'll look more like theirs. I guess they're just kind of like 6, but whatever. Anyway, you follow me, right? Make sense? Or is it weird? All right, cool. Transformation is not too bad, right? This is a cubic. What are they doing to it? Let's pull out the original to make sure. But the parent functions. Cubic goes down on the left, up on the right. Okay. That's what we got. Yes. Yeah, when +2 upward, and then is that all they did? I don't see anything else. Seems like it. Let's see. Yeah. Doesn't seem like it was stretched or anything. What about this guy? What did they do to the cubic? The center was here. Yeah, for sure reflected on the Y. So where does the negative go? Honestly, though, whether you reflect it on the y or x, doesn't it look? Isn't it the same? Right? If I flip this on the y and flip it on the x, it looks exactly like it looks the same either way. So we can think of it as x reflection or y reflection. Let's see. So I'm thinking if I do an x1, that would be fine. We shifted, yeah, +1 because it's to the left. It's a cubic, and we shifted down 2. Yeah, should be good. If you would have done the horizontal, the y reflection, um, you would have, if you put the negative inside, it would have turned into this anyway. Yeah, you can write it as, like, you mean using the y notation instead of f of x? Or oh, if you did, you'd have to do another step. Like, this is what I'm thinking here. Let me show you. So for reflection on the y, you agree that the negative has to be inside, right? So if I were to do that, it would have to be, everything would have to be negative. No, I'm sorry. Just the x. Is this graph the same as the one I wrote down? Let me look at the notes. I think I'm overthinking it, but here, flip over the y. So plug in a negative x, which I did here. Plug in negative x. Instead of doing, so my argument is flipping horizontal or vertical is the same for this particular graph. So let's see. Interesting. You would both have to be negative. Hmm. I feel like in this particular case, Megan, I think the horizontal shift reflection is just a little more confusing. I think this one is simpler. I'm trying to work it out so it can work, so you can see it, but it's not coming out. It's kind of bugging me. But I recommend just, if you see that it's the same, just flip it this way. Okay. Alrighty. Well, yeah, it's the same thing over and over again. Any of these seem difficult? What about the absolute values? That seem doable? All right then. We'll stop here then. Let me take a roll, and if you have any questions about what we just talked about or other things, let me know. Uh, is Abdallah here? Yeah, not here. Got it. Noman? Daniel Aguirre?
Here.
Trevor Brown? Joshua Correa?
I'm here, sir.
Megan, she just responded. Oh, Abdallah's here. Okay. Madison? Ella Dunlop? Stephen Fogel? Alexander Garza?
Here.
Jorge Guevara?
Here.
Kyler Just? I've seen her at all. Liliana? You're not here. Victoria? Not here today. Jose Mauricio?
Here, sir.
Victor Ramirez? Jaden Ramos?
Here.
Jolene CS?
Here.
Miranda Vallamounts? Zara Vasquez? Carlos Velasquez Loya? Frederick White?
Here.
And Dylan Willis. Okay. All right, guys. If you want to head out, you can a little early. Let me know if you have any issues with homework or the platform, something that you emailed me about. We can talk about it right now. Okay. 2.216C. Okay, let's Excuse me. Have a good night, Megan.
Have a good night, sir.
You too. Have a good night. All right. So we can do yours if you like. What's the numbers on your problem, Stephen? All right. There's just, I'm gonna use X, by the way. Is that cool? Oh, here's just 4. Like that, right? Okay. So g of t means just the original function. So let's pretend this is an X. My t's look stupid, so I don't want to write it. Minus g of 2, that means plug in the 2, right? So write the original. That's what this is. Minus the other functions, put it in parentheses, minus the entire g at 2. So 7, 2 squared minus 5 times 2 plus 4. It's ugly form. And so simplify this, that'll be 4 times 7, 28, minus 10, minus 4. That'll be 14, right? That comes out. This right here is g of x minus g of 2. I'm glad you say too, Megan. All right. So do you see what they're asking? No, this is the G in question is this one. Cool. All right. If you have any more, let me know. If not, it's all good.